Welcome to the Tim Booker channel, where wisdom deserves to be shared. We wish you a pleasant listening experience. In this episode, I will continue to decode the second half of the book, Exploring the Mind, for you. It will take approximately 25 minutes to delve into the essence of this book. The mind consists of 4 abilities: visual perception, reasoning, emotions, and social relationships. It is these 4 abilities that have shaped us into who we are today. In the previous episode, I introduced the concept of the mind and discussed 2 major schools of thought, the computational theory of mind and the theory of natural selection. The mind is essentially a system composed of computational organs designed by natural selection to solve the problems we encounter in our lives. Now that we understand the principles of the mind's existence and development, let's explore its capabilities and how they work. In the previous episode, we emphasized the importance of visual perception. This is because our reactions to the external world are built upon what we see. Our mind is a system of input, computation, and output, with visual perception being the most crucial channel for information input. Therefore, the author considers visual perception as the first-generation capability of the mind. The author states that we perceive the world through 4 senses: vision, smell, hearing, and touch. Among these, visual perception accounts for 80% of our sensory input, which is why sayings like "seeing is believing" and "seeing is reality" hold true. But how does visual perception relate to our mind? Some have discovered that the brain's visual function is actually a complex process of perception and thought. Visual organs first receive external stimuli, and then the brain processes and interprets these stimuli before conveying the information to our minds. During each visual activity, at least 32 areas in the human brain cortex are involved. This demonstrates that visual perception is constantly intertwined with the mind's computation. To illustrate this, let's consider a simple example. We not only see people passing by but can also infer their professions based on their clothing, expressions, and movements. However, have you ever wondered how we perceive the 3-dimensional world from the 2-dimensional information projected onto our retinas? The author attributes this to our stereopsis, which is the perception and judgment of the depth, height, and proximity of objects in 3-dimensional space. Our ability to perceive the world as 3-dimensional is due to the binocular disparity between our eyes. By processing the clues observed on objects, our mind eventually forms stereoscopic vision. To explain binocular disparity, it means that there is a certain distance between our 2 eyes. When we look at the same object, the images formed on the 2 retinas are not identical. The left eye sees more of the object's left side, while the right eye sees more of the right side. This is why many artists, when drawing, often close one eye and use a pen to locate the object. They wouldn't rely on both eyes for precise positioning. You can conduct a simple experiment by holding a pen in each hand, keeping them about 60 centimeters apart and aligning the pen tips. This is easy to do with both eyes open. However, when you close one eye, it becomes much more challenging to align the 2 pens. This is because we typically use the convergence of our 2 eyes' lines of sight to locate objects. When one eye is closed, precise positioning becomes difficult. Now, let's look at the 2 cues that contribute to stereoscopic vision. One is the geometric cue, which is based on the shape, size, and different states of objects observed from various distances. We all know the principle of things appearing smaller in the distance and different perspectives leading to different shapes. For example, a star fruit appears elliptical from the side but takes on a pentagonal shape when viewed from both ends. The principles of perspective drawing utilize geometric cues. Another cue is the shading cue, which we often use in drawing to add depth through variations in color intensity. When girls apply light-colored makeup to their nose bridges, it creates the illusion of more defined facial contours. These cues, along with binocular disparity, allow us to transform the 2-dimensional images projected onto our retinas into 3-dimensional stereoscopic vision. However, this kind of visual perception is not something we are born with. It typically begins to develop around 3 to 4 months after birth. Why is this the case? Because infants at 3 months of age don't yet have the ability to roll over, and they spend most of their time lying down, thus lacking substantial experience with stereoscopic vision. During this time, if you were to show them a stereoscopic image, they wouldn't react much. It's only after about 3 months that most children start showing interest in 3-dimensional objects, and this is when their stereoscopic vision slowly forms. So, why do we possess these visual abilities? The author believes that it's because individuals need to adapt to specific selection pressures in their ecological environments, which brings us back to the theory of natural selection discussed in the previous episode. Many herbivorous animals, such as horses, rabbits, and cows, have eyes located on the sides of their heads. This positioning allows them to have a broader field of vision, enabling them to react quickly to danger. However, their visual precision is relatively poor, and they cannot see objects clearly at close range. In contrast, humans and carnivorous animals like tigers and leopards have forward-facing eyes. Although this narrows their field of view slightly, it enables them to have stereoscopic vision, aiding in precise location of prey. To compensate for the sacrifice in visual range, we have necks that help expand our field of view. The author believes that it is the visual perception capabilities of the mind that enable us to better capture prey, create tools, produce goods, and accomplish many tasks that other animals cannot, such as threading a needle, driving, playing sports, and performing surgery. This makes visual perception the first ability of our mind. During each instance of visual activity, at least 32 areas in the brain cortex are involved, underscoring the significance of visual perception as a mental capability. Now that we understand how humans perceive the world, let's explore how we comprehend what we see. This leads us to the second mental ability, reasoning. Reasoning is the thought process of drawing conclusions from known or assumed facts. The author states that the starting point for reasoning is classification, as you need to classify in order to reason. The ability to classify is like placing different things into different boxes and labeling each box. When faced with different problems, you can quickly find answers based on these labels. While we may not have a clear understanding of the specific features of each object, we can observe their obvious characteristics, summarize commonalities, and categorize them. As our classifications become more refined, we can use this information for reasoning. In fact, we develop the ability to classify at a very young age. For example, children can judge whether to address a woman as sister or aunt based on her appearance and clothing. Apart from simple classification, what conditions do we need for reasoning? The author mentions 3 intellectual tools that can be applied in any field: logic, arithmetic, and probability. Let's begin by examining logic, which is a concept familiar to most. However, logical thinking is not something that develops with age. Research has shown that we already possess logical thinking abilities in infancy. For instance, in a study conducted by scientists, infants were presented with 2 experimenters, a baby's mother, and 2 toys. In the first experiment, one experimenter repeatedly pressed a toy to make it produce sound, while the other experimenter's toy remained silent. Although the toy itself was not capable of producing sound, the sound was added externally. Afterward, the silent toy was handed to the baby. When the baby realized it couldn't make the toy produce sound, they would give it to the mother to try. Based on the baby's reaction, scientists concluded that the baby believed the toy's ability to make sound was related to the person playing with it. If the baby failed to make it produce sound, they would give it to their mother. In the second experiment, both experimenters pressed the toys, but this time, the sound was produced randomly, not consistently. Again, the baby was allowed to try. In this case, the baby didn't give the toy to the mother but continued to experiment, trying different toys that still didn't produce sound. In this experiment, because both experimenters had failed at times, the baby deduced that the toy's inability to make sound was not related to the person playing with it but was a property of the toy itself. Hence, they continued experimenting with different toys. This illustrates the simple logic ability of infants. The second tool of reasoning is arithmetic, which is essentially mathematics. In general, we are naturally sensitive to arithmetic. Psychologist Karen Wynn conducted an experiment known as the Mickey Mouse Math Experiment. In this experiment, a 5-month-old baby was presented with a Mickey Mouse toy, which was then hidden behind a screen. Subsequently, another Mickey Mouse toy was placed behind the screen in full view of the baby. If the screen was removed at this point, and the baby saw 2 Mickey Mouse toys, they wouldn't react significantly. However, if the experimenter made a slight manipulation, like removing the screen to reveal 5 Mickey Mouse toys, the baby would stare at them for an extended period, as if pondering something. This experiment result suggests that even 5-month-old babies might possess rudimentary numerical abilities. Now, let's explore the third tool of reasoning, probability. Since we are adept at using information for reasoning, we gradually developed intuition about probability. However, probability can often be deceptive. One of the most common misuses of probability occurs in lottery and gambling. The author calls those who buy lottery tickets with hopes of winning IQ taxes because, in the long run, buying lottery tickets is a losing proposition. Lottery draws are typically independent random events, meaning the outcome of one draw has no bearing on the next. Yet, the modern lottery market often employs two strategies, suggesting that winning numbers will fall within certain ranges during specific time periods or attempting to predict future winning trends based on past distributions of winning numbers. Many people easily confuse this with independent probability, which is similar to flipping a coin. Every event is independent, and there's no connection between consecutive events. Reasoning abilities help us better grasp external information and make sound decisions. So far, we have covered the second mental ability, reasoning. The author introduced three tools for reasoning: logical thinking, arithmetic, and probability. While reasoning allows us to think rationally, our behavior is often influenced by emotions, which represent the third mental ability. Visual perception and reasoning help us process and understand information, but what role does emotion play? The author states that emotion is a well-designed mental module that coexists with reason. Emotion not only enriches our lives and complicates social relationships but also lays the foundation for better gene replication. Some might find it curious that emotion, which doesn't directly give us physical strength or boost our intelligence, can aid in gene replication. The answer lies in emotion's role in preference setting and helping us choose better environments while avoiding risks. Let's take the example of liking as an emotion, which is closely tied to our evolution. Here, the author is not referring to human affection but rather the fondness we feel for certain landscapes or environments. Each species has its preferred habitat, and humans are no exception. After a long history of nomadic lifestyles, our ancestors gradually began settling in various places. These areas shared common characteristics, including fertile soil, temperate climates, and expansive vistas. Throughout history, large cities and tribes have developed in such regions. Animals also exhibit similar behavior. For instance, geese migrate to warmer regions during winter, and African wildlife follows the changing vegetation patterns. Our preference for comfortable external environments is rooted in our genes, which have shaped our inclination for specific surroundings. There was a preference experiment concerning human habitat. Researchers presented different landscape images to children and adults in the United States, asking them where they would prefer to live or visit. Interestingly, the children all chose the grasslands, even though most of them had never actually been to a real grassland. Their choice was purely based on intuition. The adults, on the other hand, not only favored grasslands but also liked images of temperate forest areas, which were similar to the living environments of most people in the United States. This similarity led to a positive response from the participants. In the experiment, no one chose tropical rainforests or deserts, highlighting these preferences. Children's environmental preferences can be considered innate instincts, while adults' preferences are influenced by both instinctual inclinations and familiarity with their daily surroundings. This phenomenon extends to our current housing choices, whether buying or renting. Houses with good sunlight exposure, especially bedrooms facing south, are highly sought after and more expensive. People also consider factors like nearby amenities and safety, all of which can be traced back to our instinctual preference for comfortable environments. Beyond our living environment, we tend to like things that are beneficial for gene replication. For example, many people enjoy flowers, not only for their beauty and fragrance but also because flowering plants are more valuable than others. Flowers serve as the reproductive organs of plants, and blooming indicates a higher likelihood of producing fruit. Compared to plain grass, fruits are undoubtedly more appealing as food. Therefore, our emotional attachment to flowers is a choice of the heart in our evolutionary process. Next, let's explore some emotions that may make us uncomfortable. Here, the author emphasizes the emotion of disgust, which they believe is an indispensable emotion in our evolutionary process. Disgust primarily stems from animals such as snakes, caterpillars, bats, spiders, as well as repulsive substances like corpses, feces, and decayed matter, all of which tend to evoke disgust in us. But why do we find these things disgusting? Because these substances typically harbor a large number of bacteria, parasites, and harmful microorganisms. Contacting or ingesting these substances can easily make us sick. Therefore, over thousands of years of evolution, we have developed a sense of disgust towards these materials as a protective mechanism. Additionally, our sense of disgust can extend to other objects. For example, food that has been touched by flies or cockroaches can make us feel disgusted. When we see products made in shady factories, we are also reluctant to consume them. Our minds tend to associate these items with the bacteria carried by the disgusting animals. The refinement of our sense of disgust is not only a result of innate evolution but also of learned behaviors. In this context, the author cites the views of Professor Paul Rozin from the University of Pennsylvania, often referred to as the Doctor of Disgust, due to his research in this field. He believes that infants have both primitive innate feelings of disgust and learned behaviors. While infants may not inherently reject things that adults find disgusting, such as touching a pile of feces, parents typically educate them not to touch such substances. However, infants also exhibit natural aversion to certain things, like bitter or spicy foods, which they tend to spit out. Therefore, our sense of disgust is a combination of innate and learned responses, helping us stay away from potential dangers and passing down these concepts from generation to generation. Another common emotion we experience is fear. Many people nowadays claim to have phobias such as claustrophobia, thalassophobia, fear of the deep sea, acrophobia, fear of heights, and more. We can be afraid of various things, some of which are real, like blood, corpses, and wild animals, while others are entirely imaginary, such as ghosts and monsters. The development of this aspect of our psyche can be traced back to a structure in our brain called the amygdala. An experiment sheds light on this. Scientists removed the amygdala from the brains of mice and dubbed them fearless mice since they exhibited no fear and seemed unafraid of anything. When placed with cats, they didn't run away, instead, they boldly approached the cats. Experimenters also placed a normal mouse and a fearless mouse in a simulated outdoor environment. The normal mouse took a week to explore its surroundings within a few meters. In contrast, the fearless mouse ran around the entire experimental area on the first day, showing no concern about potential dangers nearby. Unfortunately, the fearless mouse fell off a fake mountain in the experimental area and died on the second day. Similarly, if humans lacked the emotion of fear, it would be challenging to anticipate danger. This brings us to the third ability of our psyche, emotions. Whether positive or negative, emotions are adaptive mechanisms for our survival during evolution. Therefore, it's not necessary to deliberately suppress our negative emotions in daily life. So, why do we, with our inherently selfish genes, exhibit cooperative and altruistic behaviors? The author suggests that this complex social behavior is the fourth ability of the human psyche. Social relationships come in various forms, including parent-child relationships, marital relationships, sibling relationships, and friendships. Our living environment necessitates competition, and motivations for conflicts among people naturally exist as we vie for territory, food, and mates. However, real-life situations aren't as brutal, and we often engage in altruistic behavior towards others. How do we balance our selfish genes with acts of altruism? How does our psyche operate within these complex relationships? Let's explore a few types of relationships to understand better. One of the most common relationships is romantic love. Humans face the primary challenge of reproducing the next generation. In the context of romantic relationships, the initial instincts are rooted in genetic propagation. Males tend to spread their genes by having multiple partners since they can potentially father offspring with a single mating, while females can have only one child per year and must endure a 10-month pregnancy. To ensure the survival of their genes, females seek strong partners who can provide resources and protect their offspring. Risk-taking behavior in males can help them acquire more resources and new partners because it signifies physical strength and the ability to offer protection, making them more attractive to females. Conversely, if a male acts timidly and avoids risks, he will likely face social disapproval. Women tend to favor handsome, tall, and intelligent males, statistically speaking, as individuals possessing these traits often find greater success in society. In ancient times, these men exhibited superior hunting skills, providing better security and resources for themselves and their offspring. Therefore, women gradually developed preferences for such male resources. To balance these primal instincts, civilized societies have established rules like monogamy in marriage laws. Although human relationships differ significantly from those in the animal kingdom, it doesn't mean we've completely abandoned the laws of mating systems. Once men and women marry, their romantic relationships transform into familial relationships. Next, we are going to delve into another type of relationship, parent-child relationships. From the perspective of genetic evolution, maximizing genetic success involves parents having as many offspring as possible. However, humans are different from other animals in that our maturation period is considerably long. Most children don't become fully independent until the age of 18, which means parents must invest a significant amount of effort in raising them. As older children become more self-reliant, parents typically shift their focus, resources, and care towards younger offspring. However, older children may not appreciate their parents' efforts and continue to seek more love and attention. This dynamic creates a tension known as parent-child conflict, essentially a form of sibling rivalry where parents allocate some resources for potential future children. We see this conflict when it comes to weaning. If a mother continually breastfeeds her child, she may hinder her ability to have another child because lactation suppresses ovulation in females. So why do weaned children cry and cling to their mothers, attempting to prolong nursing? In essence, they are using crying and clinging as a means to secure more nurturing resources, encouraging the mother to breastfeed for as long as possible while preventing the birth of future siblings. It's essential to note that this theory isn't intended for moral judgment but rather as a hypothetical analysis and inference of the current situation. Parent-child conflict highlights that children often desire more resources from their parents than parents initially intend to provide. Moreover, sibling rivalry is not the only instance of such conflicts. Even in the womb, there is a competition for nutrition between the mother and the developing fetus. A scientist at Harvard University, David Haig, proposed an intriguing idea: the fetus might increase the mother's blood pressure to forcibly obtain more nutrients. This extreme strategy is referred to as fetal commandeering and can manifest as hypertension during pregnancy. Haig theorized that the fetus employs a substance to raise the mother's blood pressure, facilitating the flow of more blood into the placenta, which has lower pressure. Subsequently, researchers at Harvard Medical School confirmed that pregnant women experiencing hypertension had elevated levels of a specific protein that indeed influenced maternal blood pressure. Thus, children's resource acquisition from parents begins as early as the embryonic stage. Despite these inherently selfish genes, our ability for altruistic behavior and selflessness is credited to our social systems and cultural teachings. Our society has created rules, such as contracts, courts, laws, and tolerance, which allow us to transcend savage growth and establish a complex and civilized social structure. Alright, let's summarize. In this audio session, we discussed 4 cognitive abilities: visual perception, reasoning, emotions, and social relationships. Visual perception serves as our primary gateway to the external world. Stereoscopic vision helps us capture prey and receive and process information. Reasoning is the foundation of our cognitive understanding, rooted in classification. It encompasses 3 tools: logic, arithmetic, and probability. Emotions coexist with rationality as well-designed cognitive modules. They aid us in seeking benefits and avoiding harm, ensuring the replication of our genes. Within social relationships, males seek multiple females for genetic reproduction, while females seek robust males as partners to ensure genetic replication. Natural conflicts over resources exist among humans, including between parents and children and among siblings. However, due to improved social systems and the development of human civilization, altruistic behaviors have also emerged. These 4 abilities constitute the core functions of the mind. In the book's conclusion, the author notes that the study of the mind continues to evolve, and the book's viewpoints may be revised in the future. As we explore the mind, we encounter many unknown areas, as the initial purpose of our mental evolution was to enhance survival, not to seek absolute truths. This open-minded attitude is perhaps the most significant insight the author offers. This concludes the entire content of this audio session. Congratulations! You've completed another book. Thank you for your support and attention. Please subscribe to the Tim Booker Channel audiobook channel. Like and share with your family and friends. Wisdom is worth spreading, opening the door to a brighter future. Thank you, and goodbye.